5 minutes, and those people would be roaming around all day talking to you. But I would be giving you more instructions about that closer to the time. Your first priority is now coursework 1, which is, to remind you, is an individual contribution, whereas coursework 2 is a team contribution and it is individual. So you would be submitting from your group 1 per group, and each of you have to submit your own individual one. Okay? And then this year, I would be sort of also marking your posters. The posters, I'm going to put up a template. So at least as far as the posters are concerned, everything has to be standard and it has to be uniform. I don't want anything sort of fancy. If you want to do something with your apps or the dashboard, that's your own business. But when you make a presentation, I'm going to put up a template that every group has to use that template for the poster. Closer to the time, I would be training you. And a week before, I what we call a dress rehearsal. It means that you would be going to exactly the same procedure, but only with me. So I would be giving you feedbacks and everything. So quite realistically, by, let's say, the second week of May, your apps should be completed. All the bugs needs to be looked through, and you need to sort of go through with every, go over the whole process. Again, I'm going to talk about that when we get closer to the time. And that brings me to another thing, which actually annoys me quite a bit, because there was one group who sent me recently an email and asking me to change their team members, the ones that they actually suggested themselves. First of all, I wouldn't do it as a matter of principle, because you had an opportunity to express your opinion and you have used it, and you have chosen different people in your team, so that's tough. The second thing is, I would not make any special privileges, won't give any special privileges to any other group. So, and I have already fixed your names in this group, and it is in the system. So please don't come back to me asking me to change that. This is something that you have to learn. If you are committing yourself to some sort of contribution, before actually putting your name down or signing for something, just think about it. And you should think about the people that you're going to work with or not. And if you are locked into a situation, now you are having some animosities with some of your friends or some people who used to be your friends, that's absolutely tough luck. You have to learn to get over it. And I just want to make sure that I'm not going to get any more emails of that sort, because I treat you as adults and I expect that you behave like adults, please. Alright, so that's the end of it. One other thing is that there's been, yesterday from the tutorials, Dorota was making a huge contribution to get all you guys on board. The point is, this is a very large cohort. You come from different backgrounds with different skills. I cannot really just pay attention to the really clever ones and the ones that they know this thing by heart. If you know it, good for you. You can use that to make a good contribution into your teamwork. But if you do not, you should be able to actually absorb this course. And if you are good, you should have some sort of, be a bit humble and help your colleagues. So don't get bored. We all are in the same boat. At the end of today, I'm the one who's going to mark all your coursework. So remember that. Alright. After me giving you some materialistic lectures, now we're going to go and talk about the real thing. But it's important important. I mean, I want to make sure I just get really sometimes surprised. Tutorial sessions, I'm going to go through one or two of the visualization tools. Could you please give me a show of hands? How many of you have worked with D3? Good. How many of you are introduced to things like bouquet? What? I'm asking if anybody has actually come across. Okay. So what I think I would concentrate is we would be using primarily something like D3 to do a bit of visualization of this. But most of you have got background with JavaScript, don't you? Yeah, okay. So I think that should be no problem. Right. So today's lecture I'm going to talk about data visualization and infographics. You remember that I said if you want to make an app or some sort of a system using data, you are thinking about your app. I mean, this is going to be your app. Presumably, you have thought about this. Now, the processes that hopefully you will learn from this course is that how you would collect the data, how you would clean, or what I call as wrangling the data, and there is a process of what I call visualization. Then there is what I call as deploy. Okay. Now I'm going to talk about visualization, but in the context of this process. So today's lecture is about data processing pipelines. So effectively, we are looking at a pipeline. This pipeline is that you've got your data, and at the end of this data, you've got an app. Okay? So there are certain processes that you have to do. And in order to do that, majority of stuff that you learned in the past few weeks was to do with introduction with the tools, which does this processing of the data. That is sits somewhere in this pipeline. Okay? But I'm going to talk extensively about visualization and why it is important, and also about the type of data you've got, about the relation between your data sets, and what sort of dimensional representation or visual representation of the data you would do. Okay. So, coming back to this, if you remember, I mentioned that when we were talking about data science or an app or a system in data domain, in digital domain, effectively, what you are trying to do is you want to come up with either a solution, or you want to come up with a product, or you want to tell a narrative. So everything you do with the data and with information is literally these three scenarios. Okay? And if you remember, I showed a slide last week that the sort of undermining element for all these scenarios is that how you would actually process your data. So you have got 4 processes. Collecting the data. How do you collect the data? What are the processes of collecting your data set? Sorry? Yeah, that's one thing. What else? How would you else create the data? Pardon? Script. So you create your data, okay? You create your data, you collect your data through various different sources, or you actually make your own data, you process somebody else's data. Okay? So effectively, you are actually sitting there and you are collecting, and wherever it is needed, you're making your own content or your own data set. I mean, if you are using your mobile phone to make a video of your friend and put it up on the YouTube or Facebook, you're doing the work for people of these organizations because you are generating your data. And there's also, which I'm not going to go through that, but there is a huge element of what we call as user-generated data or content. Because once you create your own content, you actually get attached to it. So everything else, all the current platforms that you express or you present your data or you distribute it or publish it, it's effectively, they're also successful, things like Facebook or YouTube, because it's user-generated content. Okay? So you can either collect it or you can create it. So these are your data sets. And then if it is your own data, obviously you need to sort of process it. I mean, if you have got a camera and you want to take a video and you want to make some sort of a fancy dubbing to it and something like that, you're processing it. You are meshing it. With cleaning the data, it's a data set that you don't know where it comes from. And it's all sorts of different ways. And hopefully, in the last 2 lectures, you have been introduced now to things like Google OpenRefine or OpenSoft, that you understand what's the process of this thing. It goes back to the idea of data mining. You chuck out all the rubbish, you take out the things which are of value for you in your own scenario. So this is the second part. The third part, which is the visualization, is what I'm going to talk about. The analyze part, this is actually very much depends on if you want to tell a narrative or you want to solve a problem. If you just want to make a product, most of these things would come and end to the visualization part. But if you are trying to tell a narrative, then you have to have another tier into your process, and that is to analyze the data. Does that make sense? Yeah? No? Talk to me. Yeah? Good. Even nodding would do. Okay, so what we do is, in the process of data collection, we can acquire the data, we can mine the data, we can parse the data, then we can filter the data, and we can refine the data. So these are what I call as data collection is effectively is when you just put everything together in a pot. The rest of it is data wrangling. It means how you would clean the data, how you sort it out. Okay? And then you represent the data, which I call data visualization. And with deploy, I'm talking about either making something or, in this particular case, make a prediction. So you would be able to use this data to say a narrative. So with Acquire, you obtain the data from a file or a disk or some other source on the network. if you are doing some sort of data visualization, that is also related to part of the data structure, which I'll come back to this. So you filter the data, you just remove all the bits that it's not of interest to you or relevant. Then you refine your data, you focus on one particular areas that is of particular interest to you. So these are all the steps that you have to take. And once actually you find the data, then you actually mine the bits that are really of interest, and then use that data set to represent it and deploy it. So in the case of deploying it, if you are making a product, that comes as a sort of standalone outcome of the thing. But if you are actually deploying it using analytics, you have to solve a problem for narrative. I mean, in this course, presumably, what you have to concentrate on are the three parts of this process, because what you're doing is you come with a solution for somebody else's problem. So how they apply that is really depends on their own application. So even if you are making a predictive tool, okay, to predict the next numbers on the lottery, you can make that. You give that to people like Camelot to use it, or you sell it on the stock market. You do not actually get involved by doing this thing. You're actually building things. So I want to make sure that you understand where your role stops. Your role stops as an engineer, as applied data scientist, where you actually make your lock-off system and hand it over. That is your job. Okay. So in order for you to understand about data visualization, I'm going to talk a little bit about how we perceive data. What is actually the reason for our biological basis of information design. And this is potentially is also important because once you are making a graphic user interface, I mean at a high level, but at the moment we're just looking at how we would be able to understand the data. What is the purpose of this data? And how best you can actually represent your data set depending on what you want to say. And then there are some loopholes. I mean, if you have got wrong infographics, you might give completely different information as what you intend to do. Okay, so the two Bibles of data visualization is the Information Visualization by Colin Ware, and the other one is Visual Display of Quantitative Information by Edward Topp. These are very old books, but they're very comprehensive, and the other ones that now, data visualization is now has got one specific branch, which is called infographics. It means that literally you go to the data set and make a graphic representation of the data. But it's not a solid, it's not a static data, it's a dynamic process. So when you are looking at, let's say, an app which it concentrates on the crime in Southampton, obviously what you have to do is you have to bear in mind how you would be able to program your tool that it takes out this continuous update onto the data. And primarily the word computer vision or computer graphics meant things like CEGs that existed like 30 years ago, you know, computer graphics or CADs and that sort of thing. But actually, when we talk about infographics, information is dynamic and it's the flow of the information, so you should be able to represent that as your data changes. And that is exactly what I'm hoping that you will be able to achieve through today's lecture. Okay. So, the human perception an object or we see a person, and our brain looks at this thing and starts processing it. So very much engineering is reconstructing the real life nature's processes, okay, within a limited possibilities, because engineering is always an approximation. So when you are trying to, let's say, make a system, this system, it has to simulate the natural or physical world as close as possible and as accurate as possible, but it never can be 100%. Okay? That's the reason things like statistics are very important. It's just the best of sort of mediocres that you select, because there's just no way you can make a perfect system. Alright? And even if you do, you have got things like unpredicted, wear and tear, and that sort of thing. So coming back to the idea of data visualization, it means that you have to think about, if I've got a data, what sort of message do you want to give that to the viewer or somebody who's going to use my app? So you don't think the way you think, you think about the way that the other person thinks. And in order to do that, you have to understand the processes and the facts which make things convey across. So we see objects because there is, I don't know, I'm a physicist by nature or by training, so I can tell you that you see objects because when you throw light at them, it reflects the light, and you can see the reflected light through the eyes. And how does actually that work? It works because if you see a cat, you would know what it is. It represents itself. But if you speak, let's say, if you do not speak Swahili or some other language, which the word cat might not represent itself, how would you be able to convey or communicate your information? So we use visualization to actually communicate and better understand the data or the subject you're talking about. Okay? So when they talk about one picture speaks hundreds of pages, it means that once you actually look at that, you would be able to make some sort of perception and understanding of what this thing is about. Whereas if you read through a book, you have to be very focused, and you have to be completely in the right state of mind. You have to have a minimum understanding of how it's been communicated in order to actually understand what it is all about. The first thing is you should be able to actually read. If you do not read, you can't understand what's on the book. So you are using visualization to actually think better about your data set and to be able to communicate it better. Okay, I'm going to put this picture up. It is a picture of the brain. It's got all these areas. I mean, you've got the backside, which is to do with movement, language, and coordination. Then you've got sort of like parts at the bottom of your brain, which is to do with memory. Somewhere in the middle is about languages. Then you have got places that is to do with planning. It's got places which is to do with being creative. And then you've got the part which is primarily to do with the vision. Okay, if you look at that, you see that, for example, the frontal lobe is the planning, thinking, deliberation, and action. Then you have got the partial lobe, which is the special reasoning, perception. And then you've got dorsal streams that you start sort of linking stuff together. what we are here interested is what is called as occipital lobe, which is actually where you start looking at stuff. So why we are interested is because the whole of computer science and how you actually make engineering, it depends on what you see in a real physical world. So this is a typical computer architecture. You have got your data or data sets or databases at the top, then you've got your CPU, and then you've got your GPU. What's a GPU?
Right.
Good, well done. And then you've got the frame buffer. What does frame buffer do? Anyone who think computer science? Sorry? Anyone?
Like a cache, right?
It's a cache. It's a buffer. Why do we need that?
There is a difference between the amount of data that GPU supplies and the amount of data display can handle, so you have to buffer it.
Absolutely. So what you do is, actually buffering is very important when you are doing the system design, because what you can do is you can effectively temporarily normalize your processes. So if you have got let's say a graphic capture unit, and then you have got an audio capture unit, and you want to make a movie, you should be able to buffer that, put them exactly in a sort of like a time slot, so they come seamlessly into the as a video. They come out as a seamless video. So this is really the simplest form of what you have got as your PC: memory, CPU, GPU, buffer, and display. So where did it come from? It came from actually our eyes. So the people who actually invented the PC, computers, they looked and tried to simulate the real life physical processes. And by doing that, they look at how the brain works. So you've got your eye, and it goes the other way around actually, but it doesn't matter. Because this is called is the one at the top, it's called the reverse engineering. It means that you see a process and then you break it down into the elements and then make the process work. So you have to think logically. So you've got your eye, and the eye is actually seeing something. Then you would be able to capture that using your retina. Then the brain starts recognizing, this is a cat, this is my friend Julie, this is color blue. I mean, you only understand things if you have been exposed to it before. And if you like, it's very much the system that you use, for example, to do content retrieval or machine learning, is because the machine learns if it's seen it before. The brain is exactly the same. If you do not know one thing, you wouldn't be able to recognize it. You might be able to start understanding what it possibly do, but you only can do it if you actually process your brain and try to make an understanding of the subject, or you learned it before. So this is exactly what happens. And when you have got a computer, this is as close as you can get. So the part of the database that you have got, or the memory of the computer, is where already this existing stored information which you have got in your brain is similar to that. So if you know what a cat is and what it means in English, you would be able to see its picture and you recognize the subject and the language which is associated with that. But if you have never seen a cat, if you live in a country, let's say come from, if you live somewhere like, maybe you go to Australia and never seen a kangaroo, people wouldn't know what it is. So people have to explain to you. Or different type of species, you know, insects or something. You won't know what it is. Somebody tells you, well, this might be a tiny bug, but it can kill you, so be careful. Don't lie in the grass in this part of the world. Okay? So that is really the process, and it's all very logical. So the same way we access the memory, that is how we would be able to actually look at the data set, process it, and then graphically represent it. So when we are looking at making a scenario by which our data to represent something, you have to think about how you would be able to break down this process into making your data speaking for itself. So, what can visualization do for us? So, you have got 4 different diagrams here. Concentrate on number A. What can you see from that? Yeah, it's different. So what it actually says is that it's different. So what about number, not about B? Can you see so you see that, again, almost at the same position in A, you have got arrows which are directed in different directions. Okay? What about C? Anybody can see the difference between?
Yeah.
Anyone? Yeah? Okay, so you can see this is much more confused because you have got individual items that they have got different orientations. It's the same with these. This is important because when you are actually doing data visualization, grouping of objects of similar texture or similar shape could be quite important. And I'll come back to that in a minute. But you can see that already, by just having different type of shapes within your data set, you are distinguishing between 2 groups. And that is, I mean, it doesn't mean anything, but by itself, it just says these 2 things are different. And how you can actually understand that your data set is being communicated through this representation. And here, what do you see? How many objects do you see up there? 1? Who says 1? Can I have the show of hands of who says 1? Okay, 2. 2 people say 1. How many say there's more than 1? Okay. Right. So, this is actually a cluster of very different objects. It's just the way that it's been formed. It gives you the impression that it's one object. But in reality, it's 2, 4, 6, 8, 10, 12, 13 cones, which are positioned at different directions. Okay? So, the object by itself can say something, but it's the way that it's been oriented and organized can give you a completely different message. What about down there? What do you see down there? Sorry?
5 objects.
5 objects, that's right. So they are, actually there are 3 lines and 3 sort of like cones of, sort of circles with sectors of them must be removed. So it looks like as if there is a star, but it isn't actually. You have got just 3 lines, and these which are organized in such a way that gives you the impression that this is a star. So what I'm trying to tell you here is, when you are trying to use visualization to represent your data and to communicate something, it's very important that you understand that the position and the organization of these data sets is absolutely crucial, because then you can come completely with a different message. Okay, what do we have here? We have here a number of different graphs which represent presumably some sort of statistic. Okay? So, in a simple case of representing the data, you can actually make it visually very easily understandable by having things like color distribution. Okay? So, this really gives you an idea. I mean, for example, here you have got the distribution of various different services for different countries. For example, who has got mobile? The mobile is represented by 24%. The people like, I don't know, health, and if you have got car, or, you know, if you have got places to live, and that sort of thing. So you can see, presumably, I mean, I don't know where this data comes from, I just took it down just to give you an idea that the distribution, already by looking at this particular graph, you would be able to associate different parts of the world with different types of life, quality of life standards. Okay, that is how you would be able to represent your data. This is a very interesting one. It brings back to the idea of how you can actually tell a narrative or solve a problem. This is a picture, it's a map made in 1854 by John Snow, who was a physician. He was in charge of looking at the outbreak of cholera in London. So what he did was he took a map. He made a map of central London. I mean, you can see it's Oxford Street, Regent Street, then Broad Street. He actually took a map of this region and started pointing out the number of people who were actually died at that particular region. What can you see from this picture? What does it actually, let's say we concentrate on literally on the central part. We don't look at the roundness. We look at the central part. What is striking on this? What can you see? Yeah? Sorry, okay, there is an X on the Broad Street, okay, and then the rest are centered around that area. So, I mean, the people come from London. How far is actually, let's say, is it the Regent Street to Oxford Street? Or it's not very far, is it? So, why do you think that this might be the case? So what does it actually say if there is nothing there down there? It means that there is no mortality, isn't it? So so there is no mortality. Okay? So why do you think that could be the case? Tell you what is the case. The case is that that particular region that there was no mortality was actually, it was monastery. And this monastery, the monks, they were brewing their own beer, and they were drinking beer, their own beer. So they wouldn't drink any water, so they wouldn't be exposed to cholera. So that is how they actually decided, I understood, okay, that is the way that this disease might be spreading through water. Because this particular people who have never actually drunk any normal water, but they drink their own beer, they all seem to be immune to this. So this is the process by which you can look at the data and you can analyze it. Just by looking at it visually, you would be able to make some sort of predictions and some sort of suggestions. Okay. What I'm going to talk about now, before we have a break, is again around 8 years ago, there was a statistician with the name of Edgar Anderson. You can look him up. He was the first one who started sort of looking at the relation of the data and how he would be able to group them in order to make an understanding of what's happening. Here you have got a set of one type of iris, the flower. So what he did was he actually started studying 3 types of these flowers. This is one type. It's called Setosa. This is another species of these iris, which is called versicolor. They are actually being collected at different parts of the world. And the third one, anyway, what he did was he started measuring the petal and septal width of these flowers, with the green part and the width of the flower. And it's actually started to sort of like looking at the relation between this data. You might think this is a completely boring stuff to do, but it was really very interesting idea that if you have actually got various different data sets, how you would be able to make an understanding what is their relationship with this data. Okay? So, these are different type of widths of these particular species. Can you make any statement about these? What do you think that could give you? What sort of message that could give you? I mean, what you can see is the trend, it follows exactly the same way. So, obviously, these are species, no matter where they grow and what the sort of growth, they will follow with the same sort of growth pattern. So, the message from this slide is how you would be able to look at the correlation between your various different data sets. And if there is a commonality, you should be able to point that out through the visualization. Okay? Right. I'm going to stop here, give you another 10 minutes break, and then we start at 1 o'clock.